This is what I call a wicked FSA algebra problem. This is the Florida Standard Assessment in 2019. Here's what happens. If I show you something simple like this, just with 5 and 3 and 18, you know what to do here. In fact, if I then show you this, I say, are these two equal? And you look at it and say, well, 5 plus 2 is 7, and 3 minus 5 is negative 2, and 18 plus 1, yeah, these two are equivalent. Well, that's basically what they're saying here. If I show you this, and then I add them, they'll look like this. See the R plus H, and over here, G plus Q, and the P plus F. So, this is consistent with this. Perfect. Now, that's obvious. Here's the question, though. If I then ask you to put this and this together, will we still get the same answer? Let's look at this big. These two coming together, will they, let's say it comes out to be x is 3 and y is 1. Will we get the same answer if we add these two together? Will we find x is 3 and y is 1 here also? And so what you want to look for is everything changed perfectly? This second line is the same as this second line. So, nothing's changed. This line is just taking these two and putting it together, so it's still consistent. So, this is the same. That will produce the same result. The temptation is to plug in. Don't do it. What you're looking for is something that is not consistent. So, one of the choices is, what happens if we have this line and this line? Will they also produce 3, 1? And this is, look at the warning. They took the original, here's the original, and they multiplied the P by 3, the Q by 3, and the R by 3. Uh-oh. They didn't multiply the R, they multiplied the H. This is not consistent. If you come up with that statement, it's not consistent, then you have to say that's wrong. What you're doing is you're looking for changes. For example, here's the original, PQR. Here's the change, PF and RH. Well, if you're adding H, yeah, you will add F. But if you're adding H, you got to add something to Q. So the F came from H came from H, but there's no Q. Inconsistent. Same thing over here. Oh, we just put the Q down here. Doesn't work like that. You can't put the Q in a different one. You got to put it up here, because this is where you added the H. So this one also is not consistent. So in this rather complicated problem, there are two problems that are not consistent. This one right here was interesting. What did they do to change the original equations? So if we look carefully, we can see that the F got 5 more, the G got 5 more, and the H got 5 more. That's perfect. This remains the same. This is unchanged. Same. It's consistent. Now, when you look at this one here, Look how they've changed the second line, the F. They've subtracted 2p, they subtracted 2q, and they subtracted 2r. 2q, 2p, and 2q. Consistent. I like it. I hope you enjoy this.